Okay, let's continue on. Let's talk about the student t confidence interval. Okay, so what we're about to see is a new distribution called the student t distribution, and we'll be doing confidence intervals based off of this student t distribution. So let me read those first few words there at the beginning. In the practice problems so far, we have assumed the population standard deviation sigma to do our calculations. And you may have picked up on this as we did those practice problems 1, 2, and 3. They always said assume the population standard deviation is, whatever the number was. What's going on there? And you just kind of think about it for a moment. In those with those confidence intervals, the idea is we don't know the population mean, right? We're finding a confidence interval for the population mean. How confident can we be that the mean is somewhere between here and here? So how is it that we don't know the population mean, yet somehow we do know the population standard deviation? That just doesn't make sense. And it's almost like you need the population mean in order to compute the population standard deviation. So what's going on here? So what statisticians do and what works, when your sample size is large enough, then your sample standard deviation is a really good approximation for your population standard deviation. So if I can use the notation that we've been using back in chapter 2, right? S is the sample standard deviation. Well, when your sample size is medium to large, then that is a really good approximation for the population standard deviation sigma. And the bigger the sample size, the better. However, if your sample size is too small, then this is not a good approximation anymore. And so what people would do for a long, long time was they would just find their sample standard deviation and they would use it as their population standard, right? They would plug it in into the formula for those confidence intervals that we just did. However, someone realized about 100 years ago, maybe a little over 100 years ago now, that for small sample sizes, this just doesn't work. So the story is, it was actually a guy, I forget his name, but he worked for Guinness, the beer company, the Irish beer company. So he was experimenting, with different barley and different, ingredients to make beer and to make Guinness, and he was doing the statistics for it. And he happened to have very small sample sizes. And he noticed this was a problem, that his results just were not fitting, with what he was doing, and he wasn't getting anywhere with his research, and so he developed a whole new distribution, and it ended up being called the student t distribution because he happened to use the variable t instead of z, right? So it's not a z score anymore; it's a t score. And the name student got put in there because when he published his work, he just referred to himself as student. Like that's how he would sign that he's a student of statistics, I guess. So this came to be known as the student t confidence interval and the student t distribution. And the idea is it's when the sample size is too small that we cannot simply replace the sigma with the sample standard deviation. Okay, so a lot of theory going on here. Where's this going? All right, so the student t distribution works in a very similar way to the z-score. It uses the t-score given by the formula you see there. Now notice that's the central limit theorem formula for the z-score with one difference. Instead of sigma in the denominator, you see s, where s is the sample standard deviation. And obviously it's not z equals, it's t equals. X bar minus mu over s over the square root of n. So now we are using, and we're not trying to hide it or make any assumptions. We are using the sample standard deviation in our formula, no pretending that this is actually the population standard deviation. Okay, the distribution also requires the number of degrees of freedom that are referred to as df. This is always one less than the sample size. So when we're going to use a StatCrunch calculator here for the student T, and it's going to ask for a degrees of freedom when we do that. So remember, the degrees of freedom is always one less than the sample size. And so you would find that with n minus 1. If you're wondering, well, what does the degrees of freedom even mean? So degrees of freedom is just the kind of broad definition is the number of ways that a dynamic system can move. Makes sense. And so it ends up being that first value is like the fixed value, and so every other value after that are these um, you know methods of freedom, you know, and so around that. So okay. Anyway, at the end of the day, if you want to know more about that, you can ask me. I don't want to get into it here. The degrees of freedom is one less than the sample size. So it turns out that the way you find confidence intervals and margin of error is identical to the original confidence interval, where we use the z-score. The confidence interval is still x bar minus the margin of error, comma x bar plus the margin of error. But now the margin of error is found with, well, a t-score. And so you see it has t sub alpha over 2 in the formula. And we've replaced sigma with s. So t times s over the square root of n. Again, the t sub alpha over 2 is just that upper t-score. Finally, we need to note just like a caution on the student T. It's the same caution that we imposed with the central limit theorem. So it says, finally, the same requirements of the sample size n are imposed on the student T distribution as those on the central limit theorem. In other words, if the original distribution is not normal, then we need a sample size greater than or equal to 30, at least 30. If the original distribution is normal, then we can use any size n for our sample. So here, the idea is that we're using small sample sizes, right? So it would have to be noted in the problem if we've got a small sample size, something less than 30, then we just need to be sure it notes in the problem that the original distribution is normally distributed. Okay. And by the way, if you were to look at the graph of a student T distribution, it still has the bell curved quality, but it gets more spread out. There's more variance. So the bell curve ends up being wider than it would otherwise normally be. Okay, let's finally get to practice number 4. It says the number of hours people sleep at night is normally distributed. Okay, so we know the original distribution is normal. Then it says 10 randomly selected people were asked how long they slept the previous night. The sample mean was 7.1 hours with the sample standard deviation of 0.78 hours. Okay, so they only looked at 10 people, so small sample size. And so they're telling us the sample mean is 7.1, and notice the sample standard deviation is 0.78. So because they tell us a sample standard deviation, we know that's the key in the problem that we're going to use a student T style versus that original style, like the original confidence interval style with the z-score. Okay, so then we will find the 95% confidence interval for the mean number of hours people sleep at night round to 3 decimal places. Okay, let's see how this is going to work. So, okay, here's kind of my recap of what we're going to do to find the margin of error, right? We saw that formula a moment ago. It's t times s over the square root of n, where we've got our t-score and our sample standard deviation. We're going to use the StatCrunch t calculator. So under calculators, look for the t calculator. And it's going to ask for degrees of freedom, so remember that that's n minus 1. Okay, here we go. Practice number 4. So they tell us that the sample mean is 7.1, so that's x bar. They tell us the sample standard deviation is 0.78. So S, not sigma, S equals 0.78. And we know our sample size is 10, n equals 10. The way we're going to go about finding this confidence interval from this point, very, very similar to what we've been doing. It's our x bar minus margin of error, x bar plus margin of error, but now margin of error, we use the t and the s over the square root of n. Okay, let's go for it. So we're going to go into our t calculator. Be sure to use the between at the top, not the standard. And you'll notice we're going to have to fill in the degrees of freedom. And I already have that written there. Hey, why is the degrees of freedom here 9? Oh yeah, it's always 1 less than the sample size. So sample size is 10. That means our degrees of freedom is 9. And then we're going to leave these two blank. You notice it still uses the X. It should really be a capital T here. That's okay. We're going to type in the answer. It's a 95% confidence interval is what the problem wants. So we're going to type in 0.95. And this is going to work backwards for us. So when you hit compute, you should get these values here, negative 2.2622 and positive 2.2622. Of course, we only need the positive version. Once we have that t-score, then we can go ahead and plug in to find the margin of error. 2.2622 times 0.78 over the square root of 10. This problem, we wanted to round to 3 decimal places. So, okay, 0.558 would be the result there. Make sure you're able to calculate those things. It looks like I'm going to pick up on the next page. So that margin of error tells us the distance from the point estimate. So we almost have it at this point. Take that margin of error, subtract it from x bar, add it to x bar. And so for us, that would be 7.1 minus 0.558 and 7.1 plus 0.558, giving us a 95% confidence interval of 6.542, comma 7.658. We are 95% sure that the actual population mean for the number of hours people are sleeping at night to be somewhere between these two values here, which is really powerful, right? So all we did was randomly select 10 people, right? So you got to be, that kind of really shows you how critical it is that those 10 people are randomly selected. But if you can randomly select 10 people, then all you need is their sample mean and their sample standard deviation, and you can figure something like this out. Okay, so just based on what those 10 people are doing, I can be 95% sure that if I looked at everybody, that the average of everybody would be somewhere between those two values. Notice that the student T makes things a little bit wider. right? So doing this with a student t distribution means that these values, that margin of error really gets bigger than it would have been for the original confidence interval with the z-score, because the idea is when you have a small sample size, you have to allow for more spread in the data, but we can still get some really good, some really powerful results. Okay, let's go on and do number 5 as well. I think we can fit that in. It says the data from the National Fire Protection Association are a sample of the number of home fires started by candles for the past several years. Okay. The number of home fires started by candles each year are normally distributed. Okay, so they're making sure we know the original distribution is normal. We will find the 99% confidence interval for the population mean. And again, round to 3 decimal places. Now notice here, they give us this data, right? So what they said, it said at the top, here is a sample of the number of home fires started by candles over the past several years. And we've got 7 values there, 5,460, 5,900, 6,090, 6,310, 7,160, 8,440, 9,930. So they took data from a sample of data over 7, looks like 7 different years in the sample, how many home fires were started. Now, obviously, this is national, so it looks like this is the entire U.S. Okay. So just with that raw data, we're supposed to figure out the 99% confidence interval. Okay, so notice they did not tell us the sample mean, and they did not tell us the sample standard deviation. Instead, they gave us the raw data. So our first task is to find the sample mean and the sample standard deviation ourselves based on just that raw data they gave us. Luckily, though, we're using StatCrunch now. Okay. So here's what is, we can kind of lay this out for us. So they did not tell us the sample mean. They did not tell us the sample standard deviation. The sample size we do know, right? How many data values did they give us? 7, right? And then we know because they've given us, they haven't given us any information. We're going to use the student t distribution because the sample size is so low. So okay, so that's kind of why I've noted t. Use the student t distribution, which means we use our formula there, and then to figure out a margin of error, t and s over square root n. Okay. How are we going to get these values? Well, it wouldn't be too bad to do x bar by hand, but don't do the sample standard deviation by hand. In fact, you don't have to do either of them. Okay, so to find x bar and s, type the 7 data values into StatCrunch. So just go to a blank spreadsheet there and type in those 7 numbers as a column. Then have it compute the mean and the standard deviation. So if you remember how to do that, the steps are go and hover over stat, and then hover summary stats or click summary stats, and then go to columns. And you don't have to title that column anything. Once you're in there, then that should look familiar from what we've done in the class so far. You can pick the column at the top and then go down and highlight the mean and highlight the standard deviation, and just hit compute, and you should have it. So I encourage you guys go and try this out right now. Type in those 7 data values and figure out the mean and standard deviation. I advise you hit pause here, go do it, and then hit play again. I'm just going to show you what these answers are, and hopefully you have the same thing. Okay, so this is what I got when I put in those 7 data values. The mean X bar was 7,041.4286, and the standard deviation was S equals 1,610.2736. So hopefully you got those same values as I did. Okay, so they're making us do a little bit more work here at the beginning. No big deal. We can do that. And of course, we know n equals 7. And now we're off and running. At this point, with all those numbers in our pocket, we go to our T calculator in StatCrunch. And we're going to figure out the upper T score. So we'll go to the T calculator. Make sure you're in the between mode at the top. The degrees of freedom is 6, right? 1 less than the sample size 7. And instead of writing out all the blank boxes, I think we've done this enough times now. In the answer, type 0.99 because we are looking for the 99% confidence interval. And that should give you an upper T score of 3.7074. Okay. With that, we can go to our margin of error formula. So we put in that T score times, and there's our sample mean, or excuse me, that's our sample standard deviation, divided by the square root of our sample size 7. Let your calculator do that work, and you should get 2,256.421, and there I rounded to 3 decimal places because that's what the problem wants. I prefer not to round these numbers here, like the sample mean and sample standard deviation. Just take all of the digits that StatCrunch gives you. But at this point, you want to round it to 3 decimal places. Okay, once we have the margin of error, we're almost there. All we need to do is subtract that and add it with the sample mean. And so I'm just going to give you the final answer here. When you add your margin of error with the sample mean, what was that sample mean? Like 7,041.4286. When you add that, or when you subtract that number and round to 3 places, 4,785.008. And when you add that number to X bar, 9,297.850. That is the 99% confidence interval for this data. And if you take a step back and think about that, like, wow, that's a huge spread, right? From almost 48,000 to almost 4,800 to almost 9,300. That's a big gap, right? That's a huge spread. Well, that's true. There's a couple of reasons for that. A big reason is it's the 99% confidence interval, which means, we're spreading those numbers out so we can be more confident that it contains the population mean. But also, that's just the nature of the student T. The student T, you're less confident, and so you need more of a spread. So if we're going all the way to 99%, there's going to be very spread. Also, the data there. There's quite a spread in the data that is given to us. The lowest one is 5460, and the highest is 9930. I mean, that just has a big spread to it already. So it makes sense that there would be a large spread to this data as well. Okay, great work. We're going to stop here.